All right, so let's keep going with this theme here of having a Lima san. Again, this guy has an A and a B, so I know he's going to be a Lima san. The difference between example 2 and this example is that A is less than B in this case, which means that our dimple is going to look a little bit different. So we still have a tip. We're going to have a dimple as well. Tip. And if you have not watched the first video, you need to go back and watch the first video, otherwise you're not going to know what I'm talking about. But tip is A plus B. So in this case, 2 plus 3 is 5. And then the dimple is A minus B. So 2 minus 3 is -1. What happens here in this picture is that since this is a -1, remember that graphs kind of go backwards when they have a negative. You can see my hand. They come around and then go backwards with a -1. So this dimple, we're going to see, actually doesn't look like a dimple at all. Haha. All right, so let's graph the rectangular here. We have a vertical shift of 2, amplitude of 3, so we go up to 5 and down to -1. Okay, so every 6 is going to be 90 degrees. It's a cosine graph, so it starts up. Let's just flesh this guy in here. All right, and then we're going to go. Remember, they're curves, smooth curves. All right, so this first point is 5, 0. So graph 5, 0 on your circle. Let me scooch this just a little bit. I'm going to count by 2s. Well, not 2s, by halves here, so you can see it bigger. 1, 2, 3, 4, 5, 0. All right. 290. -1, 180. 2, 270. And then back to 5, 360. When you do these on your own, you need to do more points. We already talked about that. Okay, so 290. 90 is straight up at 2. Now here's what happens. At -1, 180, we're going to come around to 180, which is going this way in that direction. The tip of my pen is pointing in the 180 direction. We're going to go negative, so we're going to flip it the other way. So it's going to come around to 180 and go backwards to -1 to that point right there. We'll talk about what happens in this zone in a couple days when we know a little bit more about graphing, but basically what it's going to end up looking like is this approximate, like that. And it comes backwards in on itself. And then if we keep going with the rest of it, 270. Tip is pointing downward. So +2 for 270 is down there. So this comes around and then loops back out and then comes back. It's called a Lima san with a loop. So that dimple here that was in a dimple in the last one is not actually, it's a loop. Either way, the indent, I should say, of the cute little heart is always going to be A minus B, whether it's a dimple like the last example or a loop, either way. And again, I knew that this was symmetric over the x-axis because this is a cosine graph. So it is possible to graph Lima sans without knowing the rectangular, but it is very, very helpful to know the rectangular first. Okay, example 4. This is going to be a rose curve. It's going to create a little daisy flower kind of thing. For these, it all depends on the period, what that k value is. So we know period is 2 pi over k. So our period for this is just 1 pi. We're going to want to graph all the way through 360 degrees because when we do our polar graph, we're going to want to show all the way through 360 degrees. Okay, we have no vertical shift and a vertical asymptote, not a vertical asymptote, wow, a amplitude of 4. It's a sine curve. And the period is only 1 pi. So let's see here, 3 or 6. So there is 1 pi or 180 degrees. I'm going to do my entire sine curve in this space. So it's going to go woo, so much quicker. So when I start at 0, 0, I'm going to bump up right here this is 45 degrees. Down here at 90. Oops, I missed a 0. How about there? That point, and then down here at 90. Nice smooth curve. Now we're going to do this again because it happens twice as often. So go up to 4, down, down, and up. Okay, so how is this going to look? Essentially what happens with even Ks is each one of these guys, it's not really, but they kind of represent how many petals there will be. So for this first guy, we're at 0, 0. That's unexciting. 0 at 0 degrees. Here at 45 degrees, we're going to be out at 4. That tells me where my petals start. So, and I'll show you what I mean by quote unquote start. So let's see here. This is 30. So 45 degrees is this guy right about here, and he's out at 4. I'm again going to scale by halves, and so count by 2s to get out there. 1, 2, 3, 4. Okay, then I'm back at 0, 90. So at 90 degrees, I'm back at 0. So what's happened is I was at 0, kind of came out, and then as I looped back around to 90, I came back in and created one petal. All right, now I'm at -4. Let's see if this is 90 plus another 45, 135. So at 135 degrees, so here, reference angle of 45, I'm at -4. So actually dropping down to here now. 1, 2, 3, 4. What I've done is I've come through, and this is the way it's generating. It's going through here, coming around, and dropping down to here, and coming back up. So when I graph it, it'll woo. Then, coming back up here, I'm back at 0, 180, and that's how I was able to come back here and then finish this guy. Now, if I wanted to be more accurate, I could definitely find my points at the 30 and the 60 degree marks here and here. So if this is 45, then 30 is right there. I could obviously plug this in to get the accurate amount, but it looks about 3-ish, 3.5-ish, and so at 30 degrees here, I should have been out at 1, 2, 3.5-ish, which I approximately am. We know that the actual angle here, if I were to put in a 30 degrees, would be 4 times the sine of 2 times 30, so sine of 60. So I know the sine of 60 is square root of 3 over 2. So 4 times the square root of 3 over 2, etc. All right, which is, 2 times square root of 3. Okay, so then let's keep going here. Anyway, this is getting kind of long. I have lots of explaining and wonderful things to say to you. 1, 2, 3, 4. 1, 2, 3, 4. The way this generates is it comes through here, loops back around, then loops here, and then loops there. Honestly, it doesn't matter how it generates when you graph it, but it's kind of fun to see. So I'm going to graph it one more time to show you how it generates. Woo, down here and then back up there. How do I know it has 4 petals? Because this was even, and I will know that when I have an even number, I have 2k number of petals. We'll see in the next video that not so much when it's odd.